Okay, so I wanted to create a video for those of you that were absent or just need extra help about these proving triangles congruent, so writing these proofs. So for the triangles unit, if you are proving triangles congruent, there are 5 shortcuts to having to prove the triangles congruent. So normally a triangle has 6, well, every triangle has 6 parts, 3 sides on a triangle and 3 angles inside the triangle. Instead of having to prove all 6 things every single time, there's some shortcuts. If you can prove one of these, then every other part that you haven't proven yet is also congruent. So what they are, side, 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 means that you're going to have these sides are segments. So, and when it says a side, it's talking about a segment of the triangle. So we have side, side, side is when you're going to have proven that this side is congruent to a side on another triangle. These sides are congruent and the bottom sides are congruent. So we mark sides with little hash marks like that. And with angle side means we're going to have 2 sides congruent, and they could have congruent marks here and here. 2 sides congruent on each triangle, so this side matches this side, and this side matches this side. And then the angle in between them. So the A written between the S's means the angle is the included angle between the sides that are congruent. So the angle that's congruent must be between the 2 congruent sides. It could not have been this angle or this angle. It had to have been the top. Angle side angle means you're going to have 2 angles congruent per triangle. Okay, so these angles match, and then the side in between them is congruent. Angle side is very similar, so they have the same amount of A's, the same amount of S's, but the difference is that this one, the side is touching both of the angles that are congruent. So the side that's congruent, if I look at the side, it's actually bordering both angles. And this one, the side that's congruent, is only bordering one of the angles. So you're going to have angle, side. Matches angle, side. And then HL is a unique one particularly for right triangles. If you have a right triangle, then if the hypotenuse on the triangles are congruent, which is the longest side across from the 90 degrees, if that side is congruent on each triangle, and then either one of the legs, so this is our hypotenuse, and these are our legs of the triangle, all 4 of these. So it doesn't matter which leg, just need one of the legs to be congruent, and the hypotenuse and then the triangles would be congruent by HL. So this whole paper, this one that says reference, is where all of the reasons for the proof are going to primarily be. So you would want to reference this if you're stuck on figuring out a reason for a particular statement that you can make. So some of the side reasons are it's going to be given, so it's part of the given information. You might see definition of midpoint in the given information. If you see definition of midpoint in the given information, that means that you can create 2 congruent segments. So if something is the midpoint of something else, so let's say A is the midpoint of RK, that means that is creating, this point is separating the segment into 2 congruent segments. So we have, if that's our given information, A is the midpoint of RK, we can say that RA is congruent to AK by the definition of midpoint. So that would be the reason that we use. This would be our statement. For a reflexive property, it's a side that's congruent to itself or an angle that's congruent to itself. We primarily use sides on this handout, but it could also have been an angle. So that's typically if you have a triangle where there's an overlapping side. This side that I'm highlighting or looking at is on the left triangle and on the right triangle. So if I call this BS. So BS is congruent to BS because it's on both triangles. All right, then some of the reasons for angles. So this is coming from the unit that we did last time, the Unit 4. So you have to be really pretty good at Unit 4 in order to be able to recognize these kind of things. So if you have parallel lines in your given information, then one of these angle relationships must exist. Otherwise, it would be for naught that they gave you the parallel lines. So if you have a set of parallel lines, it may look like this. And I'm going to use a pencil here so that I can erase. So we know alternate interiors when they have 2 parallel lines and a transversal. And the angles are on alternate sides, which is one on the left, one on the right side of the transversal, but inside of the 2 lines. Well, we're in the triangles unit, so instead of it looking like this picture from the last unit, it's going to look like maybe this. And I'm going to erase all the exterior parts that are not part of the triangle. So you might have an alternate interior pair inside of your triangle that looks like this. Okay, so those are going to be alternate interior angles. Alternate exterior are going to be outside of the triangles. So again, these would be congruent if the lines are parallel that they're on. So if this line is parallel to this line, these two angles would be congruent. Alternate exterior pair, if I draw my lines again, it might be like this and this. So if you have two triangles made up from here and here, which we didn't have any like that, but if we did, these angles would be congruent if these lines were parallel. Okay, these would be alternate exterior angles. So they're going to erase some of the parts of the lines that you don't really need because we're only looking at what's inside the triangles. And then if we do our lines slanted a different way with some corresponding angles. So these angles are corresponding. If I draw on the triangle, so what you could see in the triangle unit would look something like this, where you have two triangles, but the angles here are corresponding. So you want to be able to recognize within a triangle these types of angle relationships. They are going to be congruent when lines are parallel in the given information. Other two things on here, vertical angles, is if you have two angles opposite each other. So those are vertical, they're automatically congruent. Doesn't have to say anything in the given information about parallel lines or about bisecting, midpoint, none of that. It just has to look vertical in the picture, and they're vertical, and you can say that as a reason. Definition of angle, bisector has to say in the given information that something bisects something else. If it doesn't say that, then you're not going to be using that. But what this means is that you have an angle. If it gets bisected by a segment BD, it creates two congruent angles. So if angle B is getting bisected, and I'm going to call it angle ABC since it's the vertex of multiple angles. Angle ABC is getting bisected, then the two angles that it makes equal have to have B as their vertex. So ABD congruent to DBC. Okay, so that would be your statement. Your reason would be definition of angle bisector. Okay, that's an overview of some of the reasons, and then you also have for the very last one, corresponding parts of congruent triangles are congruent. So if you're stuck, you would write the if you've proven the triangle's congruent already, then all of the rest of the corresponding parts are congruent. So if you've written a congruent statement like this as a statement and said by one of the side angle side, one of the shortcuts to proving triangles congruent, then all of the other things that are in matching order, so angle B would be congruent to angle E, angle C would be congruent to angle F, side DE would be congruent to side AB. All the other corresponding parts of the triangle are congruent. Okay. So if we look at a couple of these proofs, they're going to give you some given information on these. I'm going to skip all this part. On this part, you're just looking to see what sides are marked congruent. So if there's a side AB that's marked congruent to DE, then you would just put that. AB as a segment is congruent to BC. Sorry, it's congruent to DE. Okay, so AB has one marking, and so does DE, so they're congruent. BC is congruent to EF. They have the same marking. All right. So when we go down here for the proofs, they're going to give us some statements originally, and eventually you're going to do these on your own. But they're going to give us some statements and and we're going to fill out the reasons. So anything that's in this information is given. So in this case, we have commas separating all of the given information. So we should have 3 pieces of given information that we would write the physical, like the actual word given for. Okay, this next part is key. You actually do want to mark your figure because that's going to help you tell how the triangles are congruent. Without the markings, you're just kind of guessing. And that's not going to get you a good answer on the test. So PQ is congruent to ST. So you would mark those with the same amount of hash marks. QR is congruent to TR. Same amount of hash marks. R is the midpoint of PS. So R is in the middle of PS. Ignoring everything else except for the line PS, that's telling you that R is separating PS into 2 congruent segments. The 2 congruent segments would be PR congruent to RS. They've got to be the same length if this is in the middle. So the way that we knew that this is congruent to this is because of this statement. This statement helped us derive that PR has to be congruent to SR, and it's by the definition of midpoint. So the triangles are congruent, and now we're going to pick one of the 5 ways in which the triangles could possibly be congruent. So again, those are side, side, side for this one. You just have to go back to the front of your paper. I'm not going to flip it back and forth. So SSS would be, whenever you have triangles congruent, you're going to have one of the 5 ways to prove the triangles congruent as the reason. Okay, there's some more with midpoint, but I'm going to not do every single one of these. I'm just going to do a couple of them and try to vary them up. All right, so number 5 on this next page. Given information is there. This piece of information, BD, is bisecting ABC. So you want to look at the middle letter. The middle letter is B. That means angle B is the one that's getting cut in half. So that means that these angles that have B as the vertex are going to be the 2 congruent angles. ABD and CBD are congruent. Okay, so this is going to be definition of bisects because it came from BD bisecting angle ABC. Okay, these are both given. Okay, whenever you see the same thing on both sides, that's the reflexive property, but you do want to still mark it because it's going to help you to tell how the triangles are congruent. Reflexive property. All right, and then do you guys mind if I record a video while you're doing it? Is this just... Okay, fine. Okay. Okay, so then our last reason... Okay, and I haven't marked yet that AB was congruent to CB. So now that we have everything marked, we have 3 things. So we have side, angle, side. So we have 2 sides marked per triangle and then the angle between them. So if I were to redraw this out, I have this side, an angle, and then this side. So it's side, angle, side matches on the top triangle. This side, an angle, and this side. So side, angle, side. Okay, and then on the bottom one, again, I'm just trying to hit ones that have different given information so you can kind of determine what they are, what these given piece of information mean. So HI is congruent to JG, and HI is parallel to JG. So the parallel ones get arrows, and they don't count as a side. So it doesn't count as a side being congruent, but it is helping you get either alternate interior, alternate exterior, or corresponding. So you want to be able to figure those out based off of the lines being parallel. So if these lines are parallel, if I draw some extensions here, then you'll notice that there's this alternate interior pair here and here on transversal HJ. So this is transversal HJ. And we also have a transversal here, but we're kind of ignoring it for a second. Okay, so then when we cut everything else out, we're going to cut this and this. We're going to cut this so that the figure looks the same, so that it's really talking about this angle as alternate interior to this angle. And they've already written for us that this is angle H. So it's really H is in the middle, so it's IHJ, and this is angle J, so it's GJH. So this one's going to be alternate interior angles. And then these were given. Thank you, guys. Okay. And then this, if you see the same segment again, HJ is the same as JH. It's the same segment, so you're going to use reflexive property whenever you have that same segment twice. Okay, so now I'm going to cancel out this parallel so I don't get confused, as it counts as a side. It doesn't. So per triangle, I have a side, 2 sides, and 1 angle. 2 sides and 1 angle. So this would be side, angle, side matches side, angle, side. Okay. Okay, and then I'll do number 9. I'm just going to do 2 more. If you need to keep going back through these, keep going back through these, but I'm going to try to go through all of the different reasons you could potentially pick. That way you guys are just need to recognize which of ones it's on your particular proof. So we have 3 pieces of given information and no statement that we're going to write. So you can pause the video, write all this given information. On the test, I expect at the very least that you get the given information correct, because it's provided literally in the problem and the reasons are just given. So you wouldn't put prove down here. That's one of the common mistakes. This is the one word that you do not use in the proof at all. You don't use the word prove. Everything else in the given statement, you use. The word given, this stuff, and this. Okay, so we want to mark our figure with what they've given us. Again, pause it if I've gone through this pretty quickly. All right, so we have already counts as a side. We don't need to do anything else with this. This is not a side or an angle yet. Number 2, we need to figure out what angle or side is helping us to figure out. Parallel lines, we're looking for alternate interior, alternate exterior, or corresponding angles. So if I redraw the parallel lines, and I draw this transversal first, AD. Okay, I have a set of alternate interior angles on AD. That would be here and here. Unfortunately, though, this one is not inside any of the triangles, so it's not a congruent angle inside the triangle, and we're trying to prove triangles congruent. So while these are alternate interior angles and they're congruent, it's not going to help us prove the triangles are congruent because this angle's outside of the triangles. So while that is an alternate interior angle pair, we're going to ignore that one. So then I would look for a different transversal. Okay, on this transversal, these angles are corresponding, so I'm erasing this to show you what the corresponding angles actually are, is really these two angles. Okay, so this piece of information is helping us understand that these angles would be congruent because they're corresponding. So angle B is congruent to angle CDE because of the corresponding angles theorem. Okay, so now we've used this piece of information. Okay, we still need to, this is not a direct side or angle, so we need to figure out what is this helping us figure out. D is the midpoint of BE. D is in the middle of BE, means that D is cutting BE in half, making BD congruent to DE. Now those segments are equal. So that would be definition of midpoint because we derived that from this statement. Okay, now if I erase all my parallel lines so that they don't confuse me, I can see that these triangles are congruent by side angle side. Going to number 3 on the angle side angle proofs. Is a blank one for us to fill in. I'm just going to do, like I said, 2 more, maybe 1 or 2 more. Okay, pausing the video, you should go ahead and fill these things that are circled out with the things that are circled at the top and mark your figure. Okay, this is already an angle, so we can put BAC, that's angle A, because that's the middle letter, and DEC are congruent. C is the middle of AE. C is in the middle of AE, means that these two sides are congruent. So AC is congruent to CE by the definition of midpoint. So hopefully you're recognizing if there's a midpoint and C is in the middle, it's going to be in both segments, and then AC is going to be one segment, and EC is going to be the other segment. That's all we can pull from the given information. Now we have to look at our figure and to see if we can figure out anything else. Well, we know vertical angles from the previous unit are equal, so these angles would be congruent, and I can call this BCA and ECD. And they're vertical, so they're congruent. So now these triangles would be congruent because we have angle side angle matches angle side angle. Okay, last one. I'm just making sure. Yeah, I've gone through a corresponding and alternate interior, a reflexive, a vertical. I want to go through with CPCTC. Okay, number 4. Okay, go ahead and do the stuff that's given. Okay, so JM bisects KJL. That means that angle J is the angle getting cut in half. Yeah, I'm sorry to keep going. It's okay, I'm in the video, so. Okay, so the given information, you should have it written in, and then you can mark JM bisects JKL. So J is the angle getting cut in half. So we would have two angles that have J as their vertex that are congruent. So KJM congruent to LJM. Okay, that's the definition of bisects. So whenever you have bisects in this part, you're going to have it in your reason. Same thing with midpoint. If you have it in this part, you're going to have it as part of your reason. They also told us that JMK, this angle, is congruent to this angle. So that's all we can determine from the given information. So now we're looking at the picture to see if we can figure out anything else. And this side, JM, is on both triangles. It's a shared side. So we can say that JM is congruent to JM. And that's the reflexive property. So the triangles are congruent. So we can say triangle JMK is congruent to triangle JML. Okay, and looking at the picture, how they're marked, we have angle, side, angle. That matches angle, side, angle. You're welcome. So then all of the other corresponding parts of congruent triangles are congruent. Okay, that's it. So that's the proof stuff. Hopefully you got the hang of that. Test Wednesday and Thursday for 8A. Good luck.